Hello students, I am Vishwajna. Welcome to my YouTube channel. Today I am going to discuss about alternating current and alternating voltage. This is an AC generator. Okay. By this machine we can produce alternating current and alternating voltage. In this machine we convert kinetic energy or mechanical energy into electrical energy. This PQRS is an armature placed in a powerful magnetic field. Here B is the magnetic field vector. These are the two poles of two magnets. This is the north pole and this is the south pole. Okay. This is one magnet and it is another magnet. Here R1 is our conducting ring and R2 is also a conducting ring. B1 and B2 are the carbon brushes. B1 and B2 are connected with the load resistance Rm. Here, by some mechanical energy, the armature PQRS rotates inside the magnetic field. Due to the rotation, the linked magnetic flux with the coil changes. Therefore, from Michael Faraday's law or from Lenz's law, we can explain the production of alternating current and alternating voltage. Let magnetic flux linked with the coil is phi is equal to BAN cos theta. Phi is equal to BAN cos theta. Here B is the magnetic field intensity, A is the area of cross section of the coil or of the loop. That is A is equal to the area of armature PQRS. PQRS. N is the total number of turns of the coil. Theta is the angle between the area vector and B vector. Now the induced EMF produced inside the coil, epsilon is equal to minus d phi dt. This gives BAN sin theta d theta dt. We know that omega is the angular frequency of the coil is equal to d theta dt. That is omega is equal to d theta dt. Therefore, epsilon is equal to BAN omega sin omega t. Let BAN omega is equal to epsilon 0 is the peak EMF. Therefore, epsilon is equal to epsilon 0 sin omega t. This is the equation of alternating EMF. Now we can divide this equation the equation both sides by resistance of load or impedance of the circuit. We can get the expression of the alternating current I is equal to I0 sin omega t minus phi. Here phi is the phase difference between EMF and the current. Okay, and omega is the angular frequency of alternating current. Therefore, the graph of alternating voltage is sinusoidal. Here epsilon 0 is the peak EMF. Epsilon 0 is the peak EMF. That is, this is epsilon 0 is the peak EMF. Along x-axis we plot the time and along y-axis we plot the EMF. The magnitude and direction of EMF changes with time. Now I am going to find out the mean value of AC, mean EMF of an AC. You know that the magnitude and direction of AC changes with time. That's why we had to find out the mean value of alternating voltage or alternating current. Since the total integration of sine or cos function in a complete time period is 0, that's why we have to consider the half time period, or we have to integrate 0 to t by 2, capital T by 2. Okay. Now we know the equation of EMF of an AC is epsilon is equal to epsilon 0 sine omega. Therefore, mean EMF is epsilon m is equal to integration 0 to t by 2 sine 0 to t by 2 epsilon dt divided by capital T by 2. Here capital T is equal to omega by 2 pi. Here capital T is equal to 2 pi by omega. Here capital T is equal to 2 pi by omega is equal to time period of AC. Okay. In this case, we considered the integration limit 0 to capital T by 2 because in a whole time period the integration of sine or cos will be 0. Therefore, epsilon m or mean EMF is equal to 2 epsilon 0 by capital T is equal to integration 0 to capital T by 2 sine omega t dt. Okay. Now the integration of sine omega t is minus 1 by omega cos omega t, minus 1 by omega cos omega t. That's why we can write that epsilon m is equal to 2 epsilon 0 omega t cos omega t, and due to the negative sign the limiting value will be reversed, that is 0 to t by 2. Now the upper limit will be 0 and the lower limit will be t by 2. Therefore epsilon m is equal to epsilon 0 by pi by 2 whole divided by pi by 2. This is the mean EMF. Similarly, we can get the mean current I is equal to I0 by pi by 2, that is peak value divided by pi by 2. This is the expression of mean EMF or mean current. Similarly, we can write that IM is equal to I0 by pi by 2. Okay. This is the mean current. This is the expression of mean current. Now I am going to discuss about one of the most important topic in AC. It is RMS value of EMF of an AC and RMS value of AC. You know that in of an AC there are three values. One is instantaneous value of AC, one is mean or average value of AC, and third is RMS value of AC. Among them, RMS value of AC is most important. Why? Because by the RMS value of AC or the RMS value of EMF of AC, we can express the heating effect of circuit or heating effect of resistor or inductor or capacitor, etc. Okay, that is, we can consider the heating effect through resistor by RMS value. And in a circuit board, when it is written that 220 volt, you know that this is the one of the source of alternating current, and usually this is written that 220 volt on the circuit board. And what is the meaning of 220 volt? Actually, 220 volt is the RMS value of voltage of AC. 220 volt is not the instantaneous voltage, or 220 volt is not the peak voltage, or 220 volt is not the mean voltage. It is the RMS value of the voltage. Okay. Now, we can define the RMS value or EMF or RMS value of AC such that the total heating effect of RMS value through a resistor during time T, capital T, is equal to the heating effect of the alternating voltage through that resistor during that time. Okay. We know that the EMF of AC is epsilon is equal to epsilon 0 sin omega. If epsilon r be the RMS value of epsilon or alternating EMF, then total heating effect in the resistance during time capital T, that is during one time period, is epsilon I square, epsilon r square, capital R T. This is equal to 1 by r integration of 0 to capital T epsilon square T. That is RMS value of EMF is the equivalent DC voltage of AC. Equivalent DC voltage of AC. That's why we can write that epsilon r is equal to epsilon 0 square by T integration of 0 to T sin square omega T whole to the power half. Now we can easily find out the expression of RMS value of AC or RMS value for EMF of alternating voltage. Now epsilon r is equal to epsilon 0 root 2 1 by T integration 0 to T sin square omega T dt whole to the power half. Now the integration of cos 2 omega T during total time period will be 0. Therefore the value of in the magnitude of this integration will be T. This gives epsilon r is equal to epsilon 0 by root 2. This is the relation or expression of RMS value of EMF of alternating current. There similarly we can write that epsilon r is equal to IR is equal to I0 by root 2. This is the expression of RMS value of alternating current. Okay. Now the average power of an AC circuit. We know the equation of alternating EMF and alternating voltage are epsilon is equal to epsilon 0 sin omega T and I is equal to I0 sin omega T minus phi, where phi is the phase difference between epsilon and I. Now the average power P average is equal to 1 by T integration epsilon I dt. Now putting the value of epsilon and I, we have P average is equal to epsilon 0 I0 by T integration 0 to T sin omega T into sin omega T minus phi dt. Now we can integrate the expression and we find that P average is equal to epsilon 0 I0 by 2T integration of 0 to T cos phi minus cos omega T minus phi by 2 whole within second bracket into dt, and the integration of cos omega T within a full time period will be 0. Therefore, and the cos here cos phi is only the constant. That's why we can write that P average is equal to epsilon 0 I0 by 2 pi cos phi into T. Okay. And you know that cos phi, cos phi is a power factor of the circuit, and epsilon 0 by root 2 is equal to epsilon r, the average, the RMS value of EMF, and I0 by root 2 is equal to IR, the RMS value of current. Therefore, P average is equal to RMS value of EMF into RMS value of current into cos phi. When the phi is 0, that is when the current and the voltage are in same phase, then the mean power will be maximum, and the maximum value of average power will be IRMS and V or epsilon RMS, that is RMS value of current and RMS value of voltage. When the current and the voltage or EMF are in 90 angle 90 degree, that is the phase difference between current and voltage is 90 degree, then P average is equal to 0, since cos 90 degree is equal to 0. Okay, and this occurs inside the LC circuit. And when the circuit is purely resistive, no inductor and no capacitor present in the circuit, then the power factor becomes 1 and the current and the voltage are in same phase. Next, wattless current. If we plot the P0, or we resolve P0 into two mutually perpendicular components, along x-axis P0 cos phi and along y-axis P0 sin phi. Here P0 is the peak value of the power, is equal to epsilon RMS or RMS value of EMF and RMS value of current. Here P0 is the product of RMS value of current and RMS value of EMF. Now the component P0 cos phi we use in our circuit, and this is the expression of average power or mean power. Okay, but P0 sin omega t is not used in our daily life. That's why IRMS into sin phi is known as wattless current, and P0 sin phi is known as wattless power. Now form factor. Form factor is epsilon r by epsilon m, that is average value of that is RMS value of EMF by average value or mean value of EMF. Now we know that RMS value of EMF is epsilon 0 by root 2 and mean value of EMF is epsilon 0 by pi by 2. This gives pi by 2 root 2 is equal to 1.11. This is known as form factor of alternating voltage or alternating current. So I am finishing my discussion for today. Please wait my next video. Wait for my next video. Then I shall discuss about the LCS circuit of AC. Thank you for watching my video. Have a nice day.